Alrighty then, we are on some testing and calibrating, making squares and rectangles on papers, measuring it to see if everything is squared and perpendicular and heptagon and reculang and ankylang. Yes, so let's get it on right now. Let's get it on. Okay, so I have this tool I made for practice. If your bed is not straight, it's a good tool. Your bed is probably never 100% straight anyway, so it can adjust. You know, if your bed is not super straight, you're still going to do what you do. You're still going to work that piece. You can also do some kind of system like this when you're running your motor. So if your bed is a millimeter off, 2 millimeter off, you are still going to get that cut. So if you suspect that your bed is a bit 1 millimeter off on the side, to make sure to plunge this thing. Once this pen or your tool head is touching the bed, make sure to plunge it an extra 2 millimeters. So your spring should go up at least an extra 2 millimeters, for example. Okay. So I have UGS on and I'm calibrating and testing. I'm going to move the x-axis. I'm going to move the y. All right. UGS, Universal G-Code Sender. Did I move the Z? I should give the Z a little blur. A little move. I really need to practice a bit with this stuff. You know, this is a good practice tool, a pen. Whatever you do with a pen, you can do with a tool head. Okay? So you don't waste wood and end mills, brake tools. It's good. Let's try something with the Z-axis. Let's bring it up a bit. Good. So basically what I'm doing is going down, drawing squares, rectangles, and then you can come in with a T-square and check all the corners. And if they are not squared, you can adjust your rods and whatnot. So here I have the pen touching the paper, but I'm going down a bit again to activate the spring. And now I'm going to start doing some drawing. I'm going to do a square or something. Let's zoom in on that a bit. So once you're done doing squares, once you are squared, you can then calibrate a T-square. You can do rectangles. I will only speak on what I know so far, right? If you want information, you need to go and check some people who has a little bit more understanding on CNC. So what am I supposed to do? Pull it back now? And here you have your square. So now you can come in with a ruler, measure all sides, make sure all sides are equal. If you're doing a traditional square, all sides equal. And then you can come in with a T-square if you get a T-square somewhere, and catch the angles. See if it's ready for business. So here's a little close-up. There's the tool, just 3D printed. I did not find small enough screws for this stuff as yet, right there. So I place these, but I'll find them. For now it looks great. This looks like a good square to me. I'm running the project like this on 12 volts. I will soon have its transformer for it and all. However, I'm already working on another CNC, but this time I'm trying to compare these rods with timing belts. These are regular 8mm threaded rods. They are not like the lead screws they usually build this stuff. These rods are very cheap, like a euro for one, a long one. You can get this thing in hardware stores. Your CNC will move a bit slow, which is good. I don't believe CNCs should move fast. These types of stuff, you can break tool heads, but you can step up the feed rate to get any speed you would like on the stepper motors. This is what my display look like. It's UGS and it works very fine, very good. So this is a 8. So the bolt is a 13, number 13, and the rod is 8. So get your set square, T-squares, mini T-squares that can fit on your bed, and square this thing up. So whatever projects I do with these things, it's all a learning curve. Yeah, have fun. I hope I have some adventures with this stuff. I'm not ready to put tool heads on there as yet. Tool heads do break if you don't know what you are doing. So it was a fun adventure for me. I'm already on the works with something that works on timing belts. It's already on the way. So I'll have at least 2 of these machines. I'm a bit busy. I'm even working on another 3D printer. 2 is always better than 1. While you're working on something, the other one can work on something else. And if in case one falls apart, you can have another one to keep the work up. These things may improve your work, your experiments. It's the time we are living in. Get you connected. And let's do this. I'm out.